Hey guys, welcome to ANS Solver. Today we'll be doing the concept of partial fractions of the type 3 form, which is a subtopic in the chapter of further algebra. Okay, so the best way to identify this form is look at the denominator. Here you'll have something like the x square. Okay, that's one thing which you basically need to note. And another thing you can note is that this x square plus 9, okay, this thing cannot be factorized. Okay, this is very important to know. Okay, so this is the way how you identify it, and the partial fraction form for this will basically be a over, okay, x minus 1, correct, basically the part here, plus bx plus c over x square plus 9, basically the non factorizable part, which is x square plus 9, will always be the denominator of bx plus c. This is one thing which you need to know. Correct? The non-factorizable part is the denominator of bx plus c. Now what you do is, I know I can write this as 4x minus 3, which is equal to a into, basically taking the LCM, I have an x minus 1 here, x minus 1 here. The part missing is x square plus 9 plus bx plus c. This will be multiplied to, I have an x square plus 9 here, x square plus 9 here. So the thing missing is x minus 1. Correct? This is what I basically get. Now what you do is, first, as you can see, there are two variables here at once, but here you have one variable. First find a. Okay, that's the easiest thing which you can do. Just find a. Okay, how do you find a? I know that this full part needs to be equal to 0. That means x minus 1 needs to be equal to 0. So I write x minus 1 equal to 0, which gives me my x as positive 1. Okay, now I basically substitute. Okay, yeah. Now I'll basically substitute. So I basically get 4 into 1, which is 4, minus 3, okay, which gives me 1, which is equal to, okay, a into 1 square plus 9, okay, plus, okay, here what you get, I know this full thing here will be 0 because 1 minus 1 is 0, so I know this thing will be 0 here. Okay, so I'll basically get 1 equals to 10a. So I get my a basically as 1 over 10. Now what you do is you write this full equation, okay, with the value of a inputted. So you get 1 over 10 with x square plus 9, okay, plus bx plus c multiplied to x minus 1. Now try to solve it, okay, for x. So you basically get 4x minus 3, okay, which is equal to, okay, you get 1 over 10 x square, correct, plus 9 over 10 plus, here basically you'll get bx into x minus 1 plus c into x minus 1. So now you can write this as 4x minus 3, which is equal to 1 over 10 x square plus 9 over 10 plus bx square, okay, minus bx plus cx minus c. Correct? This is what I basically get. Now I can write this as 4x minus 3 equals to, I can rearrange, get the x squares together, get the x together, and get the constants together. So I can write this as 1 over 10 x square plus bx square, okay, minus, or I can write this as plus cx minus bx, okay, minus c plus 9 over 10. Okay, now I can write this as 4x minus 3 equals to, I can take x square common here, correct, I can take x square common, so I basically get 1 over 10 plus b correct? Plus I get C minus B, okay, with x here, okay, plus in the constant I get 9 over 10 minus C, correct? So now you need to compare because you know this is equal, okay? So basically the coefficient of x square here on the right hand side is basically 1 over 10 plus b, and you equate it to the coefficient of the x square here on the left hand side. Here as you can see there's no coefficient of x square, so you equate it to 0. So you basically get your b here as minus 1 by 10. Correct? Now what you do is you can simply, you know that this thing here on the right hand side is the constant. So you write 9 over 10 minus c and you equate it to the constant in the left hand side, which is minus 3. So you write minus 3. Now you can write this as 9 over 10 plus 3, which is equal to c. So you get your c, okay, basically as 3 plus 9, okay, 9 over 10, which is basically 3.9, correct? So you can write this as 3.9 or 39 over 10, okay? Now you'll get basically this is your value for b and c. Just to confirm, this is basically for verification, okay, this is basically for verifying, okay? What you can do is, you know, you have an x here, you have the x here, you can equate the coefficient with c minus b, which is equal to 4, okay? So the c you'll get here is 3.9 minus, okay, the b, which is basically minus 1 over 10, which is minus 0.1. Now when you solve this and if you get your answer as 4, okay, that means both your values for c and b are correct, and hence the value for a is also correct. So you can write this as 3.9 plus 0.1, which is equal to 4. That means you get this value here. That means you have the value of b, okay, you have the value for c, and you have the value for a. And in this type you can even be 100% sure of your answer. So now you just need to write it in this form here. So you can write this as 0.1 over x minus 1, okay, 0.1 over x minus 1, correct? Plus you can write bx, okay, bx plus c, okay? So obviously bx plus c you can basically write this as you can write this as c plus bx because there's a negative, correct? So you can write this as 3.9 plus, or actually minus 0.1 x divided by, okay, x square plus 9. Basic substitution, I wrote this in the c plus bx or c minus bx form because my b here was negative, okay, it means the same thing, it doesn't matter, correct? So this is basically the final answer which I get, correct? Basically you just get ABC and substitute it into the form. Now we can do a past paper example. This is from 9709-2018, Feb March paper 32, okay? So here they have given us an f of x and we need to express f of x in the partial fraction form. So basically, first I write my 5x square plus x plus 27 over, okay, 2x plus 1 into x square plus 9, correct? This is how I basically write it. Now what you do is you can write this as you can see it's a type 3 form, so you can write this as a over 2x plus 1 plus bx plus c over x square plus 9. So you write this as 5x square plus x plus 27, which is equal to a into the missing part here into x plus 1 is x square plus 9. So you write that plus bx plus c into 2x plus 1, correct? You might be familiar to the LCM process now. So now you can simply write this as 5x square plus x plus 27. Okay, or before that, I'm very sorry, before that you first find a. Okay, so finding a, you know that this full part, okay, should be equal to 0. That means 2x plus 1 should be equal to 0. Correct? So I get 2x plus 1 equal to 0. So I get my x basically as minus half. Okay, this is what you basically need to know. So now you basically substitute minus half in the place of x here. Okay, so now I can write this as 5 into minus half the whole square plus minus half plus 27, okay, which is equal to, okay, I get a into minus half the whole square plus 9 plus 0. Here obviously I'll get 0. Correct? So I basically get 111, okay, by 4 in the left hand side, which is equal to a into 37 by 4. So I can cancel the 4's and I can get my a basically as 111 over 37, which is equal to 3. Correct? So now you have the value for a. So you can write this equation here with the value for a. So you can write this as 5x square plus x plus 27, which is equal to, okay, 3 into x square plus 9, okay, plus I can write this as bx plus c into 2x plus 1. Now what I need to do is I need to solve. So I can write this as 5x square plus x plus 27, which is equal to 3x square plus 27 plus, you can write this as bx into 2x plus 1 plus c into 2x plus 1. Now I can write this as 5x square plus x plus 27, which is equal to, I can write 3x square plus 27 plus, when I take bx inside the bracket, I get 2bx square plus bx plus 2cx plus c. Now rearrange, correct? So I get 5x square plus x plus 27, which is equal to 3x square plus 2bx square, okay, plus bx plus 2cx plus 27 plus c. Now you can write this as 5x square plus x plus 27, which is equal to, I can get 3 plus 2b and I can simply take x square common plus b plus 2c and I can take x common plus 27 plus c. Okay, this is what I basically get. Now you just need to compare. You have x square here, you have x square here. Equate the coefficients, so you get 3 plus 2b equals to 5. Okay, you have x here, you have x here. Equate the coefficients, so you get b plus 2c, which is equal to 1. Correct? That's the coefficient of x here. And the constant you have as 27 plus c, and the constant here is 27. So here, first take 3 plus 2b equals to 5. So you get 2b equals to 5 minus 3, which is 2. So you get your b basically as, okay, 2 over 2, which is 1. So you get your b. Now to obtain the c, you can focus on this. So you get your c here basically as 27 minus 27, which is 0. Now to verify, you can take b plus 2c. So substitute the value for b and c, and if you get your answer as 1, okay, that means it's verified. That means all the values are verified. Correct? So your b you have as 1 plus 2 into the value of c, which is 0, which is basically 1 plus 0, which is equal to 1. And as you can see, this value here and this value here are equal. So a, b and c, all three are verified. Okay, so you can write your final answer of f of x basically as 3 over 2x plus 1 plus, okay, I basically substituted a here, and now here you simply substitute b and c. So I have my b, okay, as 1. So I basically write this as 1 into x, which is x, plus 0, which is only x, over x square plus 9. So this is basically the form of the partial fraction which you need to see, because here your b is 1 and your c is 0. Correct? So when you basically substitute the values of b and c here, you only get x. Correct? So basically the basic logic is calculate a, b, c and then substitute. Okay, but only depending on the form the calculation varies, okay, of how you calculate it. Correct? So this was the concept of the type 3 form, which is a very important concept to know. Okay, so yeah, please do the next video for the type 4 form, okay, which is a very rare form, so you just need to know it, okay, so that you're 100% sure with all your concepts. So yeah, thank you very much for watching.